what's going on, everyone? Meteorologist Mike Linden here, coming at you live from the MyRadar office here in Orlando, Florida. The date is Monday, December 12th, 2022. Hurricane season is officially over, and it was a season that took us right up to the wire, if not a little bit beyond that. But that is what we are here today to chat about live with you. So for those of you that are watching on YouTube, Facebook, Twitter, Twitch, what's up to our Twitch viewers, and hey, in the app as well, be sure to have any questions that you have ready to go, and we will take some time to answer them as the stream goes on. I want to welcome in my guest. You may have seen him before across the MyRadar host of video channels, Dr. David Ryglicki, our tropical weather expert, Dr. Hurricane, as if it were, somebody that was right here with us through all of hurricane season. You and I both dealt with Ian up close and personal here. But Dr. Dave, this is really a season that it was a weird one, right?
Yes.
I mean, in the sense where there were expectations going into the season that things would be well above normal, and it seemed like at the end of the day, we kind of maybe met those expectations, but it was a wacky one. I mean, we had a disturbance in the Atlantic last week.
Yep.
I mean, super unusual.
Mm-hmm. So I think what happened was before the hurricane season began, we all thought this was going to be a big season because sea surface temperatures were warm, and it was what we call a triple dip La Nina. And usually those two things spell a big season. If you look at all the seasonal forecasts, that's what happened. Mm-hmm. And what ended up verifying was that, the major hurricanes were close and the named hurricanes were close, but a lot of the forecasts for the named storms, just the named storms, that missed. A lot of the forecasts were way too high. And we actually got shut out of August, which is really something that almost never happens.
So we have a graphic to show here of all of the names that at least were in play for this season. Of course, the big ones that stick out to folks watching at home, I'm sure, are the two ones, right? Fiona and Ian. We also had Nicole as well. But when it comes to the major storms, that being Category 3 and above, I mean, it were Ian and Fiona that topped the list. So here is the list of names here. We made it pretty far in the list of names. I mean, this wasn't like 2020 where we had to go into the the Greek names, which are no longer the case. So Owen, Paula, Richard, Sherry, Tobias, Virginie, and Walter will have to wait. We made it all the way up to Nicole there in terms of the named storms there. Again, you can see that the darker colors there, that being Ian and Fiona, those were the only major storms. But some of these, of course, caused major damage. We have a list here of the costliest storms so far this season, or at least from 1 to 5, 2 of which tipped the scales at Category 4. We'll see that here in just a moment here. So there you go, the costliest Atlantic hurricanes from 2022. Of course, numero uno, we have Hurricane Ian on the 23rd to the 30th, more than $50 billion worth of damage. Fiona at $2.88 billion. We'll ask Dr. David here in just a moment here the difference between the two. That is considerable. Another step down, Hurricane Nicole, upwards of $500 million in damage. And then things really start to fall off here in a moment. More than $406 million from Julia, which was quite early in the season, or at least quite early in the fall there in the 7th through the 9th. And then Tropical Storm Bonnie. The only summer storm there, David, $25 million. So let's talk here about Ian and Fiona, which we'll be talking a lot of here. But just right off the bat there, when you see that huge drop-off from $50 billion to 2.8, when all said and done, Ian could end up being one of the costliest natural disasters in the history of the United States. Why this such significant drop-off? I mean, $1 billion is a lot of money,
right, but
a $48 billion difference is pretty considerable.
Yeah. So a lot of it has to do with where these storms hit. And there was this study by the scientist named Roger Pielke, and he showed that if you normalize by not only inflation, but also by population, the most damaging hurricane were to make landfall now would be, I think, the 1935 Miami hurricane, just the direction it took. So the way to go think about this is with, for example, Hurricane Andrew, because there are building codes before Andrew and after Andrew in 1992. The west coast of Florida hasn't experienced as much. We had, I think it was Charlie in 2004, right? But Ian was much bigger, had a much bigger eye wall, and even though it wasn't intensifying right up until landfall thanks to an eye wall replacement cycle, it was a very, very large storm and it hit a very vulnerable area. I remember when we were doing the live stream, we got asked, would you rebuild? And the answer is, yeah, you should still rebuild. And, sea levels are rising, but the building codes on the western side of the state, they're going to have to be updated. Just like how Andrew was a breakpoint, this is going to be a breakpoint.
Most definitely. Now, Colorado State University, a strange place you would imagine for tropical weather, tropical meteorology, right there smack dab in the middle of the country. But I mean, those folks are brilliant. Of course, Philip Klotzbach there, all-star of the Twitter platform, if you will. This is the Colorado State University seasonal prediction that they put out. So at the beginning of the season, they anticipated 20 named storms, 10 hurricanes, and 5 major hurricanes. Compare that to the NOAA forecast. Remember, that is different from Colorado State University, but we figured we'd show this to you anyway. These folks are awesome. Let's take a look at the NOAA forecast now. Of course, that would be the forecast from the governing body that works with the National Weather Service, or is the National Weather Service. So there's the CSU forecast. Here we go, the NOAA forecast for the 2022 hurricane season. So to compare it to the CSU forecast, they have more of a range, right? From 14 to 20 named storms, 6 to 10 hurricanes, and 3 to 5 major hurricanes. So pretty close to what the CSU forecast was there, David. Now, again, with the way things actually played out, we had 16, or I guess we should talk about the names there, 14 total storms, 8 hurricanes, so we're kind of on the money, and 2 major hurricanes. So, Matt, can you pull up the CSU forecast one more time here so we can just compare it to what actually occurred here through the season as a whole? So, again, 14 total storms, 8 hurricanes, 2 major hurricanes. To compare that to the CSU forecast, 20 named storms, so we fell way short of that mark, David. Hurricanes, more than, or just under that, 8 is what we ended up with, 10 is what CSU called for, and then major hurricanes, they called for 5, we actually saw 2. So I'm sure the folks at home, David, are going to say the same old trope that we have heard, you and I both, I'm sure, our entire lives when we went into this field. Anytime we introduce ourselves to anybody and say, oh, I work in weather, I'm a meteorologist, and we hear tale as old as time, oh, so you get paid to be wrong 50% of the time, right? Please understand, folks, that we are trying our best here. This is an applied science. But what went wrong necessarily? That will be kind of a theme to what we talk about here. Why did we ultimately, and I'm sure this is a loaded question I'm giving you here, and we'll talk more about it as time goes on, why did we ultimately fall short of that forecast?
So what seems to have happened was that the air was a lot drier in the middle Atlantic. So I've actually got up here on the big board right now is the satellite imagery, the water vapor satellite imagery from September 9th. At 21Z. Now, the peak of hurricane season historically is right around September 1st, September 10th, that range. And if you're looking here, so that storm you're looking at in the mid-Atlantic up at the top of the screen, that's Hurricane Carl. Carl is currently, at this time, is undergoing extratropical transition. But if you look at the central Atlantic from the Lesser Antilles all the way to the African coast, there's nothing going on.
In the peak of the season.
In the peak of the season. So as it turns out, it was an incredibly dry mid levels, like 700 millibars. It was incredibly dry. There was sinking going on over the Atlantic, and I don't think anyone saw that coming. You know what separates the NOAA forecasts from, for example, the Colorado State forecasts and other statistical forecasts is that Colorado State uses current observations to project out, based on historical matching for their statistical forecasts. The CPC, they'll run a model out, 3-4 months, the climate forecast system. So they do have the benefit a little bit of, if the model is good, of seeing out what the model and what the model ensembles are going to see. So NOAA giving you that range, we came in at the low end of that range, but that's why they do it. It looks like that Phil's thing gives you a deterministic answer, but how statistically can you pick this out that it's going to be this dry? That's not one of their predictors.
Welcome to the applied science.
Yeah.
Folks. So we have another graphic here, the typical tropical cyclone occurrence areas by month. So Matt, if you can pull up that graphic here, and if we can actually look at September, because as David just mentioned, that is when we would typically expect to find something, right there in the peak of the season. There's June for you, which is right around, of course, the Gulf Coast there, up along the East Coast. Things start to become a little more common here. We see the development there for July, just off of the coastline of the Carolinas here. Big shout out to Matt. These graphics are awesome, by the way. Let's take a look now at August. So we're getting closer to the peak season. This is where you find those tracks that we see during the late summer months near the Lesser Antilles, up near the island of Hispaniola, and right along the eastern coast of the United States. We widen things out a little bit. Matt, if there's any way that we can pause the graphic here, this is the peak season, right? That bright purplish kind of color here, where you would expect to see any kind of tropical development just off the coast of Africa, right on through the Lesser Antilles, and right along the eastern coastline of the United States. Now, Matt, I know I'm asking you to do some heavy lifting here. If we can show the graphic that David has one more time here to look at the water vapor imagery, to compare it, of course, to the graphic that you just made there, just to show folks that's where we would typically expect to find these graphics. This is what we actually saw this season. So the yellow colors there, folks, that is drier air. And you can see Carl there at the top of the screen.
Earl, not Carl.
Earl,
apologies. That's on me.
Close.
That's on me.
Good.
Yeah, that was
So Earl, right there at the top of the screen, that's it. I mean, we're seeing nothing else. And this is the peak of the season. So Matt, switch on back to that graphic one more time here. We're doing a lot of switching here. So we can, again, look at the typical occurrence here by month, if we can pull that graphic up. But that's right here. Again, you would typically expect to find something in these areas. We did not see that this year. Nope. Whatsoever. Keep it rolling, Matt. Let's go into October here. You're going to see things start to peel away, of course, a little bit as we work our way toward the tail end of the season, which, of course, is November 30th, at least officially. Mother Nature doesn't care about your official dates, by the way. Again, we had a tropical disturbance last week here in December, folks. So there's October. Look at that huge drop-off. And David, speak to why we see that huge drop-off there from September into October.
So part of it is that the main source of tropical cyclone activity in the Atlantic is from the African easterly jet, and that's due to a temperature difference, which we will actually talk about, between the Gulf of Guinea from the Atlantic Ocean and the Sahara, and that creates a low-level easterly jet, and it's the waviness of that jet that usually yields they're the incubators of the tropical storms that starts shutting off in October.
Yeah, and again, Mother Nature really didn't care all that much about any of those indicators, as we dealt with some pretty significant storms. Of course, the two ones that really tipped the scales, of course, would be Ian and Fiona. So let's just segue right on in there to Hurricane Ian, a storm that probably is going to go down in history as one of the more significant storms to impact the United States. I mean, impacting the U.S. pretty much in the exact same spot as Hurricane Charlie, almost, I believe, the exact same landfall location, right? The only difference there, of course, is when it occurred in terms of the time and the date. And of course the size. Charlie a lot smaller, Ian just massive by comparison, of course. Now this is a storm that you and I both dealt with personally, let alone the fact that we were streaming live throughout the entire event. You were, of course, at your home in Lakeland. I was here at the office. I had to sleep here into the office. I mean, because let alone the fact that we were covering the storm to make sure people were aware of what was going on, this was impacting where we live, right? Yep. So kind of having to deal with it from two fronts, if you will. So you're seeing some video here from storm chaser Aaron Jajak, as well as from meteorologist Matthew Capucci, both of which were chasing this storm as it made landfall there in southwest Florida, a spot that typically doesn't see hurricane landfall much like this. And of course, those guys were right in the eye wall. Some really wild stuff. It was a pretty touch and go moment there for both Capucci and for Aaron. But David, we're looking here at the imagery, if you will, of Ian as it worked its way toward landfall. So break down what we're looking at here. Sure.
So what we're looking at here is the radar-derived radial wind of Ian as it starts making its approach into Punta Gorda, Florida. So what was going on here was that what's going on here is that basically the warmer colors are winds moving away from the radar. So the radar is right in the center of the image that's in Key West. And then the greens, blues, and purples are moving towards. So that is where it made landfall. Now if we come all the way back, this should loop. Oops. Did not. So if we start again. So when we start this loop, what you're looking at here is actually an eye wall replacement cycle. So it'll come all the way back to the beginning of the loop, And you should see this smaller circulation and then a moat, what we call a moat on the southern side. So as we move forward, I remember when we saw this live, I thought like, oh, this is some dry air entrainment going on. It should weaken the storm. Very obviously did not happen.
Good old Gulf of Mexico.
Good old Gulf of Mexico. And as we iterate forward,
There it was.
Yep, you get an eye wall replacement cycle. And that's part of the reason that Ian's eye wall was so large, that it went through this eye wall replacement cycle, which is not uncommon for a storm of Ian's intensity at this time. So as you can see here, we have winds of 120. These are wind speeds in knots. So there's 120, and since it's saturating the yellows, you're probably seeing 120, 130, 140 knots. And it makes landfall. It underwent a slight weakening, if I'm remembering correctly, from the NOAA P3s. But since Ian's eye was that large, yeah, if we pause it right here, it made landfall. This is right around Punta Gorda, Florida. So this is what was going on, and as it goes farther inland, it starts to erode, it starts to weaken, the usual. But this is really what I want. But going back to the beginning, that's really what I wanted to show. Is the eye wall replacement cycle? That's what caused Ian's eye to be so large.
And we're talking about a storm. Excuse me. It made its way all the way up to 155. I'm losing my voice. Excuse me. 155 miles per hour, falling just short of a Category 5 hurricane. I mean, looking back at 2018, where we had Michael, that at the time was a Category 4.
Right.
Of course, once NOAA went back and looked at it, eventually upgrading it to a Cat 5. Is that something that we may see here, or can we rule that out?
It could happen. I know Andrew was initially thought to be a 4, then they went in and did a reanalysis, and Andrew was bumped to a 5, and Michael, same thing. So it is possible. It's not unprecedented. But what's working against Michael is that, so Andrew and I believe Michael were intensifying up until landfall, whereas the planes, at least the NOAA P3 planes when they were flying in there, and the Air Force ones, were indicating that Ian had probably leveled off or it started decreasing in intensity. So since the D-intensity DT was in the either flat or going down, probably not. It depends if a sensor gets caught in what we call like eye wall mesovortices, localized vortices that live in the eye wall, local wind maxima. You know, the hurricane experts and the surveyors, they're the ones who make the call, being like, is that really the sustained wind? Because that's what you want. I believe it's the 10-second sustained, I do believe. You want or 1 minute sustained, something. You want sustained winds, not just gusts from mesovortices to make that call. And
for folks as well that are thinking like, oh, will this be a storm that gets retired? I mean, it's too early at this point to say that, but it certainly seems that way. I mean, if you were betting, this seems to be one that will eventually be retired. That will be decided at a later date, much like how Dorian was decided at a later date to be retired. So we're looking at some video here from Aaron that he shot on his drone. I mean, just take a look here at the damage. I mean, it is really significant. The storm surge was just wild from this storm as well, with tons of water making its way inland where it doesn't belong. And look at the beach location there. The shoreline just being pushed inland. Look at those boats. I mean, those don't belong there, Dr. David. Those do not belong there. And
I distinctly remember during this live stream, someone asked me, said, hey, I have a boat in the harbor, and what's going to happen to my boat? I'm like, probably going to wind up in somebody's living room.
Yeah. I mean, it's a really unfortunate reality when you live in a location like this. I mean, folks, Southwest Florida is beautiful. I mean, coastal Florida is gorgeous, right? And these folks know the risks from living in these locations. The one thing, of course, is that this part of Florida does not anticipate or has not really dealt with anything like this, at least historically more common than for people that live along the eastern coast of Florida. And of course, going back to hurricane season from 2021, not seeing any landfall whatsoever. Not to say that Florida was due, but again, folks, this is the state of Florida. It's right there in range of all of these potential landfalls, and that's what actually ended up occurring here. So, Dr. David, with Ian as a whole, I know you have some graphics to share here. Ian made landfall, 155 mile per hour winds there in Southwest Florida. And then from there, I mean, it was off to the races. Of course, weakening in terms of its overall intensity on its way through Central Florida, but just making a ton of damage along the way.
Yes. So that's a big part of what happened with Ian. So stronger hurricanes tend to weaken faster than weaker hurricanes simply because they have farther to fall. And to maintain a hurricane, you need very precise conditions like sea surface temperatures, which we'll talk about momentarily. So I think that was a lot of the issue is, the National Weather Service, when I worked at the National Hurricane Center, Ken Graham, who's now the director of the National Weather Service, he was big on messaging. And he always said, 20 people are going to leave way too early, 60% are going to leave when we tell them to, and then the last 20% are just not going to listen. Mm-hmm. So he's wondering, how do we get these people out? Because some people can't get out. On these islands, once they made the decision to close those,
you're stuck.
You're stuck. So and also what caught people off guard, and I remember this when we were doing the live cast, is that Ian dove to the right way quicker, because when it was
Tampa was in the cone.
Tampa was in the cone. Lakeland was right in the center of the cone when it was coming off Cuba, and I remember that warning that was issued the advisory right after it came off Cuba. I think 2 hours later the eye was already outside the cone. So I think that's a big thing of what happened, is that it wasn't expected to make that right turn
as sharply as it did.
As sharp as it did, and as soon as it did.
Right. Now, for folks as well that are wondering at least what went wrong here, it's not necessarily that the forecast went wrong. Mm-hmm. That cone is, of course, meant to cover a wide range of possibilities. It's that as time goes on, it begins to focus in more, right? I mean, from your time at NHC, what's going on with those forecasters that are deciding where that cone, how the cone's going to look?
Okay, so what the forecasters do is they provide where they think the eye of the storm is going to go.
That's the center.
The center. That's what they're forecasting. What the cone is, and this is really difficult messaging, is that the cone is a climatological statistical property. So based on I think it's the 2/3 of the previous error at that given time, 24 hours, 48 hours, that forecast lead time, that's the width of the cone as it goes out. It says nothing about model variability or ensemble variance or anything like that. It's just historically, that's what it shows. Now, the forecasts have gotten better. Brian McNulty, which I unfortunately don't have, Brian McNulty showed an image where if you overlay the cones on each other, every couple of years, it's getting narrower and narrower. The forecasters do a great job. Mm-hmm. It's just that sometimes, things like this happen. Is that none of the models saw this happening, and what turned out was there was a trough that was digging down over the eastern United States, and a ridge got kicked out of the way over Bermuda, and that moved a little bit faster, just a little bit, just takes a few hours, and you got that eastward turn. Yeah,
I mean, a humongous amount of damage. Again, that number, where is it here? $50 billion worth of damage, if not more. And for those communities along Southwest Florida, very likely reshaped forever and could take forever to rebuild. I mean, we're watching the life cycle of Ian here. You have to really pay close attention to watch that eye wall replacement, as Dr. David suggested there, as we really saw that eye just explode. One thing as well, and we have in these loops here as well, was the sheer amount of lightning around the eye of the storm. That's one thing I know that Aaron Jajak, David, had mentioned, that he had never experienced anything like that before chasing a hurricane, just the amount of lightning that was present within the eye. Was that unusual for you to see as well?
Yeah, it is. It is unusual because to get lightning, you need, in regular thunderstorm, you need up and down right next to each other.
There it is, right there, folks.
Yeah. Okay. So what you usually normally get are updrafts and downdrafts next to each other, and it's snow particles actually that rub electrons off each other, and then you get charges in the cloud. So it is unusual to get this on a hurricane because it should be, or usually, up everywhere. So for whatever reason, Ian was very electrically active. Now that doesn't mean, or it's still a little unclear if a lot of lightning means intensification, if it means weakening. That part is a little unclear. But yeah, a lot of lightning like this isn't very common.
So let's look at the sea surface temperatures, the graphics that you have up here. So we have our sea surface temperatures from the 26th of September. They are on the left, and then on the right, the anomaly, or how far away from things normally should be.
Yes.
So break it down for us.
Sure. So on the left-hand side is your sea surface temperatures. Now, Ian went over, basically found the warmest waters in the Atlantic Basin right here on this little hook of Cuba, and then went over another batch of warm water just off the northwest of the Florida Keys. Now, the other part is that if you look at the anomaly, so the anomaly is deviation from a long-term climatology, basically the average, I think it's from 1980 to 2010. So, yeah, Ian basically found the two warmest areas in the Atlantic Basin, and that's part of the reason why I was able to maintain its intensity. Because normally when a hurricane goes over some of the greater Antilles, like Puerto Rico, Hispaniola, Cuba, the mountainous terrain is probably going to weaken them. I know this is a depression in the terrain in that little piece of Cuba, but Ian basically didn't weaken. It incited, or may have incited, an eye wall replacement cycle, but the fact that the water was so warm on both sides, especially on the front side, that's what allowed it to maintain its intensity. And this is part of the problem that we have with hurricane seasons that have warm SSTs but don't have a lot of storms, is that as you look at the anomaly plot on the right-hand side, it's green, which is positive, greens and yellows basically everywhere. So you're looking at, and this is in Celsius, so you're looking at 0 to 1 to 1.5 degrees Celsius warmer than normal, on top of the fact that it is already warm. And to stress this point, if we go to the next image, this is on the 30th of September after Ian has already passed.
Shaking things up.
Yeah, shaking things up. So you can see that there's a lot cooler water between Florida and Cuba. You get upwelling off the Florida coast, and the actual sea surface temperatures have degrees. So they're still warm, mind you. They can still support tropical development. They didn't this year. But that's part of what happens when you have warm SSTs and not a lot of hurricanes, that if something made it through, which Ian did, that dry area, that sinking, that wind shear, that anomalous wind shear in the Caribbean, this is what happens. It has this, all the fuel is there for this thing to blow up.
And we had chatted about the sea surface temperatures leading up to Ian's development. I mean, just seeing it on models, days, and weeks out here. And that one thing that I know we continued to talk about was the fact that the Gulf was so still. Nothing had disturbed it. I mean, it was like putting a pot of water on the stove and just leaving it there, right? So now, of course, we get Ian coming on through, and that certainly shook things up in a major way. So once Ian made its way through Central Florida, I know that you have a graphic there of the observation station just completely dropping off the face of the cliff. That's a really interesting one to look at. And of course, with the amount of rain that it brought into Central Florida, I mean, just totally nuts. I mean, it went right over top of Disney World, mind you. And Disney World doesn't just shut down. I mean, we're talking Hurricane Irma, the pandemic, 9/11. That's it. That's the only times Disney shuts down. They shut down for this with the sheer amount of rain that Ian brought through Central Florida. So yeah, just look at this. I mean, this is just speaks to how strong Ian was when it made landfall. So what are we looking at, David?
So what we're looking at here is the ASOS station, the automated weather system at Punta Gorda Airport. So in the red line is your sustained wind, in the blue line is your gusts. And the reason I show this plot, so you see the gusts ramped up to about 110 knots. But then, as you can see, it was offline for about a week. So that's how wiped out they were in Punta Gorda. They couldn't even get the weather service, the weather station back online. But yeah, this was right in the path of the eye. Now, and I remember some people, when we were doing the live stream, they were doubting how intense Ian was, but proof is right there. This was a Category 4. And one other thing is that when we were doing the live stream, I also pulled out the observations from Lakeland, the Lakeland airport, since I do live in Lakeland, and you can basically see right exactly where my live stream contributions cut out, as on 0Z on the 29th, which would have been around 7 or 8 p.m. local time. That's where I lost power, and that's when the Lakeland airport also lost power and stopped observation. At least they got back on their feet about a day and a half later.
Yeah, I remember when we were live streaming there, we were, you and I were both chatting. It's like, okay, any minute now, any minute we're probably going to lose. And as of course we're saying that, there you go, power's out. And of course, it worked its way all the way through Orlando. I remember, of course, we slept here at the office, and then the following day, I mean, our entire parking lot was filled up with trees and debris. I mean, the road was flooded outside of the office. I mean, that's small potatoes compared to what the folks in Southwest Florida dealt with, of course, not being ignorant of that fact here. But this is the path in terms of its intensity. And just look at its approach there right into Southwest Florida. I mean, the folks of Tampa and Clearwater dodged a bullet in a major way, having not had a major hurricane landfall in Tampa, right, David, since the early 20s,
yeah.
Right? Mm-hmm. This was close.
Yeah,
this was really close.
Yeah, that's doomsday. That's doomsday, and because for the same reason that Miami was such a wreck after Andrew, is that they hadn't had to rebuild from a major hurricane in decades. Mm-hmm. So yeah, no, that's the major worrisome scenario is if a hurricane makes a major hurricane makes landfall in Tampa in that right angle, and that east, northeast approach, that's the big concern. Or if it's just a little off on the front right side, pushes all that water in, yeah, that's real bad news.
Yeah, well, 100%. So before we move on to Hurricane Fiona, which actually, of course, came just before Ian here, is there anything else you want to mention about Ian?
No, I think it's pretty well covered. It did do a little bit more damage, and there was more storm surge as it came off the coast and didn't. They thought it was going to, since it was under a lot of shear, thought it was going to weaken more than it did. But the Gulf Stream was still warm on, again, because there were no TCs. The Gulf Stream was warm on the eastern side of Florida, so there was a little bit more storm surge and erosion damages on the South Carolina coast. But
yeah, so Tampa avoids the landfall there, but folks, it's going to happen at some point. As to when, your guess is as good as ours, but it will happen at some point. But the counter remains 100 plus years for the city of Tampa. So Hurricane Fiona would be the next hurricane that we wanted to chat about here, being that it was the second strongest storm in terms of its intensity, a Category 4 hurricane, a much longer path in terms of the distance that it traveled when compared to Ian here. Similar, but in terms of the landfalls that it made, two total opposites. Of course, Puerto Rico and then Canada. And Canada will remember Fiona for a very different reason than the folks in Puerto Rico will remember it, being that it was the strongest storm, at least in terms of its lowest central pressure to make landfall in Canada ever. Peak intensity of 130 miles per hour, causing roughly $2.88 million in damage. You can see here in the imagery there, look at that insane convection there as it made its way through Puerto Rico. Of course, massive mudslides occurring in the island of Puerto Rico with a ton of rain. But there was concern at one point that Fiona was going to make its way toward eastern Florida. That did not happen. But boy, David, it pretty much threatened the East Coast all the way northward until it eventually made landfall there in Nova Scotia.
Right. So one of the things that was interesting about Fiona, Fiona is interesting for a few reasons. Now, the big one is that it was really intense, but it also set pressure records in Nova Scotia. And part of that is part two, it underwent extratropical transition and it merged with a mid-latitude trough, which is not a million miles away from what the perfect storm did. I think it was 91. So
shout out George Clooney.
So right here is I'm going to show you an animation of the GFS analyses, and what you're looking at here are 500 millibar height anomalies. So I just removed the zonal mean that basically highlights where the troughs and the ridges are. So greens and oranges and reds are your ridges, blues and purples are your troughs. Fiona is going to be one of those.
Our low pressure.
And the grays are your streamlines here at 200 millibars. They're not really that important for this evolution, but we're going to start on September 12th, and eventually you're going to see Fiona develop its own little circulation right here. So right now over Puerto Rico, that little circulation to the west of Puerto Rico, east of Hispaniola, is your representation of Hurricane Fiona. So there's a weak ridge that is sitting above it, and then a ridge sitting over the eastern United States. So what happens to Fiona is it gets squeezed between these two ridges, and you have this trough digging down. So that's what happened with Fiona's. Why, it was always a question of, would the trough pull it westward? How would these ridges set up? And it basically, like I said, it just squeezed north. It kind of like I believe it was the Long Island Express in 1938. It didn't move it moved pretty quickly, but if we go to the very end of this, and this is, so that is
there
what
it is,
happened.
right there.
Yeah, so if we back up a little bit, this is what happened, is that it merges with the trough up over the Canadian Maritimes, and that is why the pressure ended up being so low. The wind speeds I don't believe were that intense. According to the best track, it was only around 60 knots. It was a tropical storm at the time, but this is what happened with Hurricane Fiona to break all those records in Canada.
And for one thing I want to mention as well, coming later this week, we will have another live stream entirely in Spanish with meteorologists Erica Lopez and Joseph Trujillo Falcon. They're going to be talking a lot, of course, about Puerto Rico, about Hurricane Fiona and its impacts to the island of Puerto Rico. Now, of course, this storm David, coming just before Ian. I mean, it was just one after the next here. Of course, both becoming Category 4 hurricanes when all was said and done here. But what are you going to remember most about Fiona when it comes to what it eventually did, where it eventually went?
Well, I think that's what it's going to be more of a memory for people in Puerto Rico. Unfortunately, like, man, they just cannot catch a break in Puerto Rico. And even at the time, it wasn't even that intense. It was only a Category 1, if that. But it just dumped, what, about a foot of rain, more than that.
In a day.
Yeah, in a day. So that's part of what you're going to remember. Now, luckily, it missed Bermuda, right?
Yeah, that's right.
It barely missed Bermuda.
Barely
missed Bermuda, but then due to that, that vortex merger with that trough, you were setting records in the Canadian Maritimes. So that's probably what it's going to remember. Normally storms like that, they're fish storms because it followed a very certain path where it hooks out to sea. It just, again, those poor, like if it just been maybe 40 miles in the other direction, probably wouldn't have gotten to the east, probably wouldn't have gotten
a game of inches, right?
Yeah.
So this is video that you're seeing here that Aaron shot in Nova Scotia. I know leading up to this event here, Aaron was really taken aback by the eventual path that Fiona took. I mean, for the people that live in Nova Scotia, you're probably not anticipating dealing with a hurricane, let alone a Category 4 hurricane that far to the north. But Mother Nature is tricky, huh? Yeah, I mean, that really is what it boils down to here. One thing, David, I'll say that I'll remember a lot from this season. I mean, this maybe is something to say for the end, but hey, I'm already here. Was the path that these storms took. I mean, really kind of the worst case scenario for each and every one. The angle that they took on their final approaches, that being Ian, and of course that being Fiona, with Fiona going straight from the south to the north, as you mentioned before, a wall of water in terms of the rain and the storm surge for the island of Puerto Rico. And then, of course, Ian coming in right there along the southwest of Florida, pushing just tons of water inland with the storm surge and of course, with the rain coming off of it as well. So that's one thing I'll remember from this season for sure, the angle of incidence of both of these storms here. But is there anything else you'd like to chat about, David, when it comes to Fiona? I see you have the SSTs up here, so let's talk about them.
Yeah, just real quick with the sea surface temperatures. Much like with Ian, what happens is that if you have a warm ocean and you don't have storms churning things up, you end up with warm sea surface temperatures, and that's probably part of the reason why Fiona was able to maintain its integrity so far north. So what you're looking at here are the sea surface temperatures on the 18th of September on the left-hand side. This is in Celsius, and on the right-hand side are your anomalies. Now, the cool spot right there at 65 west, 28 north, that's actually from Earl. So what Fiona did after Fiona chugged on through, you can see Fiona passed to the west of Earl, and it basically had anomalously warm waters all the way up to Canada.
Earl kind of just carved a path for it right on northward.
Yeah, and then if you look at the sea surface temperatures, you can basically see if we toggle back and forth, there's Earl's on the right, and then just to the west of that is Fiona. So Fiona actually did a lot of upwelling and cooled off the Atlantic. This warmed up by the time Nicole showed up. Part of the reason why Nicole was able to form.
Sure.
But this is what happens when you have a warm ocean. You don't have a lot of hurricanes. Just again, and if you look on the left, you can actually start to see this cold tongue of water. It's not really it's just upwelling water brought to the surface by Fiona's passage.
I mean, a really wild storm here. I mean, 2 Cat 4s, of course, Nova Scotia, folks. I mean, I can't reiterate that enough. That's way to the north. I mean, it's barely on your map here, right? So, gosh, I mean, Canada and Southwest Florida are going to be linked forever because of this season. Really wild stuff. Folks, if you have any questions for myself or, of course, I mean, for this guy right here, Dr. Hurricane, get your questions in. Of course, we are streaming across all of our platforms. You can see them all above my head right up here, right? Be sure to like and subscribe on the YouTube channel. Smash that like button. It really helps us break through the algorithm, of course, and then subscribe to the channel. It's totally free, folks, to subscribe to the channel, and then, of course, turn on those notifications. That way you always know whenever we drop a new video, or of course whenever we go live, like this video here, which will likely be chopped up into all little bits and bobs. So now that we've arrived here at the end of the season here, David, of course there are many other storms to chat about. Of course, Nicole, there's Tropical Storm Gaston. Of course, I appreciated all of the Disney memes with Tropical Storm Gaston. We had Elsa. Was that last year or the year before? It was recently.
Last year.
It was recently. My brain is like mashed.
What we found out with
potatoes
Elsa
at this
is that
point.
people liked Frozen 1 a lot more than Frozen 2. That's based on the memes. That's what we learned.
Yeah. So when it comes to this season, as a whole here, again, what went wrong, so to speak? I know we talked about dry airs we just looked at before. So let's look at the season as a whole here. I know you have all sorts of colorful graphics to look at here. I know you're very excited to share them. Let's take a look at them.
Okay, so what went wrong, and this is the key feature of what's going on. So what we're looking at here is your relative humidity at 700 millibars, so the lower to mid vertical levels, and it's the anomaly, the departure from the 1991 to 2020 climatology. And what you're looking at here is that in the reds, this is about 5% relative humidity below normal. This is coarse resolution, but it basically shows that in the mid-Atlantic and in the Eastern Caribbean, it was very dry. Now, part of that could be that there were no hurricanes there. That's part and parcel to what they do. But we saw at the very beginning that satellite imagery on September 9th. It was this huge area, dry area, basically stretching from, I don't know, Belize to Spain. And that was a really big thing that I don't think, I don't know how you model this or where this came from, because I know when it comes to intra-seasonal forecasting, like changes on 2, 3, 4, 5 weeks, we talk about things like the Madden-Julian oscillation, which is something that starts way out in the Indian Ocean and then propagates along the equator to our basin. You're talking about equatorial Kelvin waves, like these large, low-scale features, but they move. Like they have time scales of a couple weeks. This was a persistent feature that basically sat on us for the entire season, and there might be another low frequency oscillation that we don't know about. Now, one of the other things we want to take a look at here is omega. This is vertical velocity at 300 millibars. So this is at the top of the atmosphere. So blue are downward anomalies and green are upward anomalies. So in the blue here, even before you get to the Lesser Antilles, you have anomalously sinking air, and that's going to suppress convection. Now, when you have a hurricane, they can usually blow through something like this, but in the cradle, in the MDR, it takes a lot of things to go right to get a hurricane to form. And something like this sitting over the main development region, not great.
Works against it, right?
Works against it. And this is the zonal anomaly from August to September. So this is 200 millibars. This is a westerly,
way upstairs wind.
A westerly and eastward wind. And normally you see this pattern. We see this jet over the greater Antilles of Jamaica and Cuba and Hispaniola. This is something you actually normally see in like El Nino years, because what El Nino does that the convection in the Eastern Pacific fires up what's called a Walker circulation. So it's up in the Eastern Pacific and it jets out into the Atlantic, and that's why you have suppressed hurricane activity. So in a La Nina year, and I know this was a big thing that has been talked about a lot, this is very unusual. And then the last part, so what we're looking at here is the zonal wind, 700 millibars zonal wind over Africa. So this is what we're also talking about, the African easterly jet, because if the jet isn't wavy or if the jet slows down, the jet's not going to be as wavy. If it's not as wavy, you're going to get fewer African easterly waves. And what you're looking at here is that these yellow-red contours on the southern side of the continent, that means it's normally westward wind. And if you have an eastward anomaly, that means the west wind is slowing down. And if you have a slowing down jet, less wobbles, less wiggles, fewer waves.
Right.
So it was an amazing coincidence and occurrence where you had sinking air in the Atlantic, dry air in the Atlantic, anomalous upper level westerlies in the Caribbean, and it appears the African easterly jet had actually slowed down this year. So all of those together ended up with our forecast bus. Even though the SSTs were warm, even though it was a triple dip La Nina, all these things contributed to an underperforming hurricane season relative to what we thought it was going to be.
That said, once the dam broke, right? I mean, we got Fiona and Ian, seemingly back to back there. So were these indicators present at the start of the season, or was this something we had to wait to watch to develop?
Well, it looks like they were there. So the anomalies I picked were from the start of the season. This one in particular is July to September. Mm-hmm. So apparently these were there most of the entire time. It's just that at the time, it's hard to pull these out because these are anomalies over the whole month. And if it's July 2nd, you can't get a July anomaly on July 2nd. So this is something that for whatever reason, this is what Mother Nature said, yeah, I'm just going to do this. So that's the tricky part. when you do statistical forecasting or seasonal statistical forecasting, is that there are other parts of it that, we've talked about this before, is like the Western Pacific, for example, way below normal. Like the Atlantic eventually got to about average. The Western Pacific is half what it should be. So just like this, what is missing? What oscillation, what relationship, what is missing? What are we not seeing?
So what will you take away then from this season, that one, looking ahead to 2023 and beyond, that you'll go, well, in 2022, X happened, can't forget about X. What will you take with you?
Well, the question is, where did this dry air come from? So it looks like part of it is due to the sinking. If we trace it back, where does this sinking come from? Who leads whom? And the question will also be, can we predict it? Because the question is, okay, why did this happen? And is it predictable? So it's basically pulling out those two pieces of the puzzle here. It's like, why was it sinking? And what other climate signal, what other oscillation caused this sinking? And that's what we're going to have to look at. Because I remember it was either 2013 or 2014 on the Hurricane Research Division, their morning discussions, they refused to say that, the year that would not be named, because they didn't want to draw comparisons to it, because you could get a blow up at any time, like you saw with Fiona and Ian. But it had very eerie similarities to that. You had this, in a La Nina year, you had this upper level westerly jet in the Caribbean, and you had dry air in the Caribbean. So it has happened before. Why? And what lessons can we pull from this?
Let's not forget, too, that even though this season may have, to some people's measurements, exceeded expectation, it still ranks as one of the costliest seasons when we're looking at the top 10. Looking at a table here, number one, 2017, of course, that's Hurricane Maria, $294 billion, with a B, billion dollars. Number two, this is still wild that it's right here. Can you guess, David?
Katrina?
There it is, 2005. See? Put him on the spot there, folks. He doesn't know I was going to ask him that question. 2005, $172 billion in damage. Number three, 2021, $80 billion. And then we go number four, 2012, number five, 2004, and then number six, 2022. Of course, we had some top-end hurricanes here, one of which, Ian, that represents 50 of that $56 billion worth in damage. But all told here, still an incredibly costly season where people did unfortunately lose their lives. Upwards of 300 or so people unfortunately lost their lives here. I mean, we would prefer that number to be zero, but as forecasting improves, as alerting improves, it seems as though that people out there are really taking heed of what could happen. And I think for folks that live in Southwest Florida, that they'll look back at this season as a very unfortunate reminder of the sheer power that Mother Nature possesses. So when it comes to the season, is there anything else, David, that you'd like to mention that you'll take with you, something else that you learned from it, or something wacky about the season?
Well, I mean, the wackiness was the dry air, but it's more the point that it only takes one. And if you think, even going back to '92, to Andrew's year, it was basically Andrew and then like Bupkis the rest of the season. But we all remember '92 because of Andrew, and we'll always remember 2022. Again, there was a lot of damage from Fiona, but we're gonna remember Ian. And all it takes, it was just one. So we're gonna remember that, like I said, from forecasting and from all that part, it's gonna look like a below normal. When people analyze this, 30, 40, 50 years from now, our kids and grandkids look at this, they're gonna see 2022 being a dip. But if you dig in, Ian is in that dip.
Yes.
So I think that's the whole point for people on the coast, for people who do live in hurricane damage prone areas like Florida Peninsula. It just takes one. So even if you go through years of no landfalls or no major land, no, don't forget there have only been 3 Category 5 landfalls since 1950. It's Camille, Michael, and Andrew. That's it. But it doesn't have, the category is not the whole story. And Ian was also huge. Like, that's what separated, and I know I've mentioned this like a zillion times when we talk, is Sandy. Again, growing up in New Jersey. And a lot of the people didn't take Sandy seriously because it was only a tropical storm, and the year before was Irene, which went through and was just dumped a bunch of rain. But Sandy was completely different in that the waterfront in New Jersey, where I grew up, never going to be the same.
Right. I mean, that's another one too, an area I grew up in as well. I'll never forget pictures back from my dad, who was working in New York City at the time, of the skyline dark. That was crazy. That was so surreal to see something like that. Now, there's so much more that we can dive into, like ACE. I know that you probably could talk about accumulated cyclone energy all day long. I mean, we're talking about the probably the number one expert in tropical weather meteorology, or tropical meteorology, sitting across from me right here. But there's so much more that we can talk about here. But David's actually going to be shooting some videos that will be up on our YouTube channel and across all of our platforms coming soon. Looking at the difference between a tropical and a subtropical storm, as well as weird shaped eyes in hurricanes. So a lot of a lot of exciting stuff coming from Dr. David here. But I guess that's probably going to do it for this stream here. I guess one thing I would want to mention here, I talked about before Disney World closing. I mean, that doesn't happen all that often. I know that Matthew Capuccio will be happy that I mentioned this here. Waffle House is closed in Southwest Florida. I know that you folks might think that that's silly to mention, but you're talking about a restaurant that informally is part of an index with FEMA called the Waffle House Index. Whether or not a Waffle House stays open or it closes. If it stays open, maybe it's not as bad as weather could potentially be, but when it closes, okay, now it's really time to take things very, very seriously. And the Waffle Houses in Southwest Florida closed in anticipation of Hurricane Ian's landfall. So we had both Waffle House and Disney. They don't want to close, folks. Got to reiterate that. They do not want to close, and they had to for Ian with the amount of rain and wind that was coming through Central Florida. So quite a year in terms of the top-end hurricanes, and quite a year in terms of other weather events that we've seen so far this year. I mean, I can't believe 2022 is almost over here. I mean, 2023 is right around the corner. I think I'm done with my holiday shopping for my family. I think so. I'm gonna have to double check that before the week is out here. But is there anything else that you'd like to mention before we wrap things up?
No, it's just this was my first tropical season with you guys on MyRadar, and thank you for giving me the opportunity to talk about. I love these things, so just want to thank you for giving me the opportunity to talk to all these people and to talk to you about tropical cyclones.
Awesome. And Sandy Rose, I see you in the chat here. Weird hurricane eyes? We'll love to see that. So there you go. Sandy's excited for that video. So keep it tuned right here on the YouTube channel, of course, in the app, Facebook, Twitter, and Twitch as well. Be sure to follow us across all of our platforms above. We've got David's social media information in the tweet from this video. We'll pop it in the description of in the description box on YouTube as well. And I should also mention that Matthew Capuccio, as well as Matt Highland in the back there, made their way to Southwest Florida to look at the damage from Ian and, of course, tell the people stories from the ground as part of a video called Hurricane Ian Ground Zero. That is up on our YouTube channel. A phenomenal, phenomenal job at telling the story, the real human impact story from Ian. You can actually see some video of it there. I mean, truly, truly wild to see some of that video. So we'll be sure to link that video in the description as well. So that's probably going to do it for this stream here. Again, David and I could probably sit here and talk to you guys for the next day about hurricane season, but we got to wrap things up here. Of course, David is shooting some additional videos for us, so look out for those. Again, the difference between tropical and subtropical storms and weird-shaped eyes and hurricanes. Can you guess what those hurricanes are? Let us know in the comments down below, and we will try our best to answer those questions. So for the guys in the back, big shout out to Matt and to Jack, and of course, tropical weather expert Dr. David Ryglicki, thank you so much for joining us. Safe trip back to Lakeland. And of course, for all you folks watching at home, thanks a bunch for joining us. We'll see you back here in the next one. Stay safe and stay dry. See ya.